Let's talk about identity matrices. An identity matrix is a square matrix where you have ones along the main diagonal and you have zeros everywhere else. And we tend to denote them by I with a subscript for the size. So identity matrices are always square matrices. And this is I2, this is I3, and so on. Now the thing about identity matrices, they're just called identity matrices, but they're really the multiplicative identity. And so that means they act like one when it comes to multiplication. This down here says if you have, if A is an m by n matrix, then if you multiply A by im on the front or in on the back, then you just get A back. So here's an example, and I want to do this one just by hand because it's going to be simple. If we multiply this matrix by the identity matrix, now from what we just read before, it's going to give us back the original matrix, but let's do this. If I take this, when I multiply that by the first column, I just get 2 plus 0 plus 0. When I multiply it by the middle column, I get 2 plus 1 plus 0. And when I multiply it by the last column, I get 0, 0, 1. And then essentially the same thing happens on the next one. When I multiply 350 times this first column, I get 3 plus 0 plus 0. Then I get, I get 0, 5, 0. And then I get 0, 0, 0. So multiplying by that identity matrix, this gives us back the original matrix. And same thing happens here. Normally, when I teach this in a classroom and I've got a board, I tend to use two fingers, and one finger I go across the first matrix, and the other one I go down. And I can't really do that here, but that's what I'm trying to get across when I do this. We do 1 times 3 plus 0 times 7. Then we do 1 times 4 plus 0 times 9. Then for the bottom row, we get 0 times 3 plus 1 times 7. And we get 0 times 4 plus 1 times 9. So, it just gives us back the original matrix. And this is, I'm not going to work this out, I'm just going to write the answer, 3, 4, 7, 9. The point of this example here is identity matrices are one of the special cases where if you multiply, if you've got a square matrix and you multiply it by an identity matrix, whether you put the identity on the front or on the back, it gives you the same thing. So we saw the other day that matrix multiplication in general is not commutative, but this is one of those exceptions where the order doesn't matter. One more quick thing to mention, Octave can automatically generate the identity matrices for you. If you want the 2 by 2 identity matrix, you just type in I2, and it'll give it to you. Or if you put in I5, it'll give that to you. Now, why does it use the word I instead of just the letter I? It's because if you just use the letter I, Octave uses that to mean the square root of -1. All right, so if you need an identity matrix on Octave, you can do that. And if you want, say you're doing something and you need the, you're going to use the 3 by 3 identity matrix a lot. You can define something like this, I3 equals I3, and now you've got it as a variable. All right, so that's enough here, and I'm going to make sure my cat doesn't tear my curtains.